Hey, Steve Basic Architect. Yeah, we're somewhere in the Midwest. We're out here at our farmhouse project out here. And as you can see, we have our geothermal wells being drilled. Out here we have 12 wells. They go down 200 feet. You can see he just attached another length. They're 20-foot lengths in pipe to develop that drilling down in there. So why don't we see if we can't catch up with one of these guys. We'll get an in-depth talk about exactly what they're doing. So let's see if we can't get their attention. All right, so Paul decided not a problem. He's gonna come and he's gonna tell us everything we ever needed to know about geothermal, because you've been doing this a long time.
Yep, 30 years.
30 years. Now this is your company?
Yeah, me and my partner.
You and your partner. Name of the company?
Iowa Geothermal.
Iowa Geothermal out of?
Grimes, Iowa.
Grimes, Iowa?
Yep.
All right. And you've been drilling for 30 years?
I've been drilling for 30 years. My partner, Ray Coon's, been drilling for about 45 years.
Wow. That's a lot of holes.
Oh, yeah.
And you put in some pretty big systems, right?
Yes, we have put in quite a few large systems. We did a 700-hole system for a high school up in Des Moines.
He said 700 holes, right? We have 12 holes here.
Yep, you have 12 holes here. These are 200-footers, which is primarily what residentials are. The 700 hole was for a big commercial building, a high school. They were 300-footers.
Okay, all right. And obviously geothermal is all about, once we get down to a certain level, we hit steady state temperature.
Right, once you get about 15 feet below ground, it's 55 degrees.
Right.
Worldwide, 55 degrees.
So in the summertime, we're pumping heat into the ground.
Correct.
To make the liquid cool. And then in the wintertime, we're extracting heat to make the liquid warm. And then we take it inside to either heat in the winter or cool in the summer.
Correct.
So, and we're using the ground to do that.
You use the ground, and all the ground do is transferring the heat to try to get it back to 55 degrees. That's all it's doing. So you're only extracting or putting in 6 or 8 degrees.
Right.
That's it.
Yeah, you're not coming out here with 100 degree where you're putting 40 degree temperature in.
Yeah,
so hence the 12. Now, I know the answer to this, but is there a dimension that like these can only be so close to each other?
We put them 15 foot apart. That's what we do.
Right.
The dimension is they overlap. It's a 16 foot diameter hole that they pull from. Yep. So you could literally, if you wanted, have them closer. Gotcha. We choose 15 foot because that's gives you an 8 foot deal.
And the reason for that is you don't want them too close where this one's trying to put heat in and this one's trying to put heat in, and you've already kind of met the limit of the ground.
Correct.
And there's no more.
There's nothing more for it to do. Yeah, it's overlapping and you're done. Right.
So we want to do that. Now, I know in New England, we do ones a lot deeper. Sometimes we do 350, 500 feet. I mean, it's all kind of tuned to the soils, right?
It's tuned to the soils and the building.
And the building.
How much ground you have. If you're short on ground, you got to go deeper because you don't have enough to make the 15-foot grid. Let's say.
Here we have multiple acres, so the 200-foot 12 is probably better than going to 4 500-footers.
Correct.
Or whatever the case is. Now, I see we have the drilling rig there. It drills in what foot sections?
20-foot sections. Each one of them rods are 20 foot long.
Okay.
And it drills in 20-foot sections. It's a mud rotary system, which means we're pumping water through the drill pipe, down to the bottom, out the bit, making the cuttings flush up the hole.
Okay.
The bit's 4.5 inches in diameter. The hole, because the water jetting is about 5 inches in diameter, the cuttings float up, go through that yellow hose, across that shaker, and shake out, and we recirculate the water.
So it's basically a closed loop on the water. You're just constantly using the same amount of water.
We use the same water.
But everything that we see accumulating in the pile there is basically what we're drilling out of the hole.
That's what's coming out of the hole.
Now, we talked a little earlier, and you told me something that I was somewhat fascinated with. This is pretty hard drilling here.
It's not that the ground is hard, it's the ground is real sticky.
Gotcha.
So the hole wants to collapse back on itself real quick. See, when we get to a certain depth, we have to drill real slow to let the cuttings come out and make the hole.
Right.
If it was hard, like rock, I drill way faster.
So it's like drilling through taffy.
Yep, there you go.
Versus kind of drilling through a hard candy or something.
Right,
yeah.
if it was drilling through a hard candy or easy topsoil, it'd go quick. This is just like you said, taffy's a real good example.
Yeah, so everything wants to stick to the pipe. It
Yep.
just, everything wants to make your life more difficult.
Yep.
So,
But I'm used to it.
I hear you. I mean, is all the ground in this area pretty much the same? Do you see, like, if I travel 50 miles from here, do I have kind of the same cutting
No.
situation?
The river's close. That's
Okay.
why we're on this side of the river.
In what river?
The Raccoon.
Raccoon, okay.
So we're on the wrong side of the river. The other side of the river would have been hard. The river
Okay.
wants to bend, and it's bending towards
On the short side.
Right. So we're
Because it's easier to cut the river, right?
Yep. The
Understood.
river, water's funny that way. It takes the path of least resistance every time.
Now, I see the big drill bit there. Why do we have that here?
We do things a little different. We don't have a big mud pan out here and a poor guy out there just shoveling all this away. We drill about 1.5 foot hole that's 2 foot in diameter, and we set a big sand guzzling pump in there to suck all the cuttings up. That's why our holes are this big around, only at the top, that deep.
I gotcha. So it's just basically you're creating a little sump pip.
Yep, that's exactly what it is.
Basically suck everything out of there. And then each of these loops, it is just a single down and up.
Yep. It's manufactured. You can see on the end of that pipe, there's a U-bend.
Yes.
It's manufactured on there, so the pipe goes down, turns around, comes right back. Each one of these are.
So do you buy those pipes in a very specified?
We buy them in we buy them in, like, these are classified as 205s, except for you can see some extra coil here.
Yeah.
That one's a 250 foot
Okay.
loop.
Okay.
So
Sometimes they have it, sometimes they don't, right?
Sometimes you get a 250 foot loop, sometimes you get a 205. Obviously the 205s are better because we're only going 200 feet.
I got you. Now, are you guys just responsible for drilling? Do you make all the connections here?
No, we're responsible from the pipe that come out of the basement.
Okay.
There are pipes that are coming out, the supply and return. We're responsible from that point out. So we'll hook all these up to a manifold.
Okay.
Run them into the supply lines that are up there next to the garage that come out of the building.
So talk a little bit more specifically. We have 12 loops, right?
Yep.
12 lines out to the yard, 12 lines to the house.
No, 2 lines to the house.
Okay.
1 supply, 1 return.
Well, I'm saying from the holes though.
Yep, the holes will all go into a manifold.
And the manifold is outside the
Out
house?
in the yard.
It's out in the yard. Is it buried in like a
5
bucket
feet,
or?
Nope, 5 feet down. When we hook these up, they're all heat fused.
Okay.
So it's a 500-degree iron. You melt the outside of the pipe, the inside of the fitting, put it together, and if you put it in a pull test, you pull the pipe or the fitting apart before you pull the joint apart.
Understood. Understood. And obviously the manifold we don't need access to because you're burying it in the ground.
Yeah, no, you'll never need access to any of this again. We
Gotcha.
air test everything before we bury it.
Okay.
So it's under 100 pounds of pressure for 24 hours, holds it, we're done. We don't, you'll never have to get in there. The pipe's guaranteed for 150 years.
Is there a sequence to the attachment to the manifold? Like this one goes number 1, this is number 2, or do they just all plug in?
What we buy, the manifolds we buy look like your hand.
Okay.
So they're a nice Y shape here and they all come in, so you don't have to go in any sequence at all. It's just 1/2 of the pipe goes to the supply side, 1/2 goes to the return. That's it.
And then those 2 pipes, you bring them inside the foundation wall and you turn it over
Yep.
to the HVAC guy.
Yep, he hooks onto that.
I gotcha. And then you're off doing the next one.
Right. And this system, we put antifreeze, propylene food grade glycol is what we'll put in there.
Okay.
Just in case for some reason we get where it's below 0 for a month.
And the ground really
The ground
freezes up.
really gets cold.
I got you. Does that glycol, does it have any better transfer than say if I filled with water?
Yep. It transfers the heat better and it lubricates all the pumps that are inside.
Gotcha. So it's a win-win-win to go with the glycol mix. Well, I don't know, do you have any party comments? You certainly answered all of my questions.
No, I'm good. I mean, the only other thing that we didn't talk about is our other machine that's back there. It's a grouter.
Okay.
There's a hose, big hose reel, we'll drop that to the bottom, and we grout from the bottom up. We displace all our drill cuttings out with geothermally enhanced grout.
Because the tubes need a conductive device.
Right, they need to touch the ground.
They need to touch the ground. So you're doing a synthetic ground, basically, with
That's
that
exactly
ground.
what it is. If I had some, I'd show you real quick. But
yeah,
it's
like a cementitious material.
It's consistency of peanut butter.
Okay.
And it's that consistency.
Does it stay loose like that, or does it hard?
It's peanut butter forever.
Oh, wow.
I mean, you come back in 20 years and dig up 5 feet to where my loops are
you
buried.
Just pull those up.
It's peanut
Out
butter.
of peanut butter. Well, that's awesome. Well, Paul, I can't thank you enough. I know you guys are busy. You're working hard. I appreciate you taking time.
Not a problem.
That's Paul from
Iowa Geothermal.
And we're somewhere in Iowa. I'm Steve Basic Architect. Until next time, long live our buildings.